It was
that's my whole comment is like this phrasing is jacked. Yeah, I don't. Yeah, because that word means not related, and so okay, fine. But then there's a whole paragraph about her birth, which means he is related. The child is related to his mom, not adopted.
I mean,
and then there's another living child, and so I thought, well, maybe what they mean is it's a different dad. George, it's time. It's 1:30 on the dot.
Awesome.
Other people are clearly late and don't respect.
I sent Eastwood to go get one of the things that I forgot in the library, so hopefully he'll be back. Okay, so
I saw him walking towards the library.
Welcome. This is essentially my final for the class. I think it's crazy. I felt like we just started this class 2 weeks ago, and this has been one of the most enjoyable classes I've had in the entire time here. So we can go right into it. We all know that the disease that I've chosen is fatal familial insomnia, and we're going to get into that eventually. I do want to go over some background things first, and one of those background things is sleep, because sleep is a big part of FFI. But before I go into sleep, I would like all of us to take a rest. Let's have a deep breath out, nice. Good morning. That was a beautiful sleep that we just had, beautiful night. 8 hours of sleep, pristine. We feel energized, ready to go about our day and tackle whatever is going to come at us. And so, these slides are very familiar. These are from our reticular formation slides we've had in lecture a couple weeks ago. We understand that the hypothalamus is one of the control centers of sleep, as well as the thalamus, which is important later on. We understand that the suprachiasmatic nucleus controls our circadian rhythm. And we understand that the brainstem is responsible for all the GABA flip-flop that happens within REM sleep, that it controls our muscle paralysis during that time. And we know sleep is important for a lot of things. Memory consolidation, learning, which is mainly the thalamus job, protein synthesis, recovery, and our metabolism function, right? And Renee, you might recognize this slide from our brain health class. This is a huge study done on the perception of sleep quality. And the amount of hours you get is redundant, because what's more important is how you feel you slept. And so if you have a poor perception of your sleep quality, you're at higher risk for these following conditions, which is extremely alarming, considering that less education is one of those, and depression is 20% more likely. Where is that? Right here. 20% more likely than if you have a good perception of sleep quality. So this is just something to take note of. And we've had another fantastic day of learning. I think we learned a decent amount. Let us again take a big deep breath. Good night. Good morning. That was 6 hours of sleep, or no, 5 hours of sleep. I can't tell. It was okay. 5 hours is kind of like the average for us right now, so it's fine. But we could do a lot better with more. Before we go into FFIs, we need to talk about prion diseases, and it's pronounced prion. I thought it was prion, it's prion. And so Eastwood is going to be on the way with those. Okay, awesome. Let me draw it on the board. Here we have our healthy prion proteins. They're known as PRPC because they are cellular. They are really nice guys because their function is neuroprotection, cell adhesion, which is the combination of cells, and immune function. They activate T cells and control inflammatory responses. PRPSC is a scrapey form, which is its misfolded form, which is going to look like this for our drawings. This guy has the ability to turn our healthy guys into folded prion proteins, which is potentially devastating when we go into the genetic mechanisms of what happens. And prion proteins are mostly found within our brain and spinal cord. Here, within our drawing, we have T cells as blue, B cells as green. I forgot a B cell there. And we have our dendritic cells. Thank you so much. We have our dendritic cells as black. This was the activity I was going to show you. I was literally going to show you the prion proteins and be like, oh my goodness, guys, these are healthy ones. This is crossed, turns them all crossed. Those are really interactive activity that I've had planned. But we're ready to do it. It's pretty cool. Wow. And so, thank you, Eastwood. And so here is our dendritic cell. Our dendritic cells are found within all our body. They are antigens, so they are responsible for initiating immune responses, and they have a lifespan around weeks to months, whereas these white blood cells have lifespan of years. And so here we have a couple healthy prions inside of our dendritic cells. And what happens when our misfolded protein encounters a dendritic cell, our dendritic cell does something called phagocytosis, which is cell eating. It will eat the cell and put the cell in, eat the proteins and put the proteins inside what is called the vesicle. And immediately red signal starts going off because this is a misfolded protein that should not be inside our dendritic cell. So our famous cell fighters called lysosomes, Lisa, she's my goat, they start attacking and try to break down these misfolded proteins. But PRPSC, our misfolded proteins, are resistant to lysosomes. But don't worry, because we have a different way to combat misfolded proteins, because we get those all the time. And it is the ubiquitin to proteasome pathway. Ubiquitin, essentially what that does is it tags the misfolded protein and says, boom, 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 here it is, and sends them to our proteasomes, which is our scissors, our garbage disposals of our cells. But, once again, prion proteins are resistant to this type of change. This process is partial, and so it's resistant to both type of changes, thus being able to spread within our dendritic cell, essentially infecting every single prion inside the cell, which has some potentially alarming things going forward. But a lot of times when we experience prion diseases, or when someone experiences, it takes 20 plus years for people to start feeling symptoms. And that is because these guys are all around the body and they need to transfer up here. And so that travel time takes a long time. And remember, these guys only have a lifespan of about weeks to months. And so they can die along the way, to which the prions have to do the process all over again. Once they make the way to the brain, they have the ability to cross the blood-brain barrier. So when they are close to a neuron, they're able to send the proteins inside the neuron. Red flag starts blaring, activating our microglia, the natural defensor of our neuron, and it'll turn it into like an amoebic state, which sends in cytokines, which are C-reactive proteins, to combat these misfolded proteins. They're often drawn as circles within textbooks. But once again, prion proteins are resistant against cytokines. And if we know a little thing about cytokines, they are neurotoxic. So they're toxic to our neuron, and this process, this entire thing leads into the dementia symptoms we see within prion diseases, which is extremely important when we talk about Creutzfeldt-Jakob disease, which is what Melissa was curious about, our last two classes actually. This type of prion disease always leads to some sort of dementia. It can be genetic, but most of the time it is sporadic, which is terrifying because that means we have no idea why the heck this happens. Mad cow disease is the most famous one. It is a variant of CJD because mad cows is mainly in cows. And we can also receive this variant by dura mater transplant, which is crazy. That if someone else has these prion proteins and you get a little brain transplant, it's just, or like a dura mater transplant is crazy. These are symptoms that you'd see within someone with CJD. We see insomnia as one of them. We see problem coordination, blurry vision, memory loss, personality changes. A lot of these are dementia-related symptoms. And there's a bunch of different types. There's kuru, which is cannibalism. You essentially laugh until you die. There is, there's other ones that lead to dementia. We've learned a lot. I think it's time for us to rest. Let us take another sleep and see how we feel tomorrow, because we didn't have like much good sleep last night. Good morning. That sleep was not better. We had 3 hours of sleep now, not 5. We feel exhausted. We're starting to move around and people are noticing, and we're finally into fatal familial insomnia, which is what we're going to talk about. We're going to talk about the history of this, and we're going to the presentations that this prion disease has, which is this right here, while going over our case. So it's gonna kind of match and match, which is the case you all read. We're going to go over patient 0 of FFI, essentially, which is one of the first medically recorded case. His name is Silvano. He is an Italian And his story is that in 1983, he was dancing with his mom on a yacht. So he's a rich guy. And he started sweating profusely. And he knew this was a symptom for something that he's been lying dreading for a while. So he runs to the mirror and he sees that he has pinprick pupils, which is meiosis. He immediately went to the doctor and he went to the Neurological Institute of Bologna in Italy, that's how you pronounce it. And he told the doctors, I'm going to die in a year. This is what's gonna happen. I know this is what's gonna happen because I've kept a family tree all the way to the 1760s.
Oh,
Dang.
With the entire family being cursed with this disease. With the first one being, or the first recorded one being a doctor, ironically enough. The neurologist is obviously like, what the heck, you're crazy. But Silvano assures him that this is gonna happen and shows him his symptoms, and insomnia starts being prominent. And so the neurologist takes him seriously, and we're finally, in science is finally able to see the first proper EEG of fatal familial insomnia, which is big because it is completely different than every single textbook out there on EEG at that time. And when he inevitably died, about 7 months after his admission, he donated his brain to science, which is amazing because he was the first to do so. And they found holes in his thalamus. Here's a video of some of the clinical presentations of those with FFI, including our guy Silvano. Let me turn on this guy.
Often you will see him and other patients performing gestures like combing their hair or washing their hands or handling objects.
Silvano and the others were unable to drop into a deep REM sleep, and sleep medications only accelerated their restless descent towards
See the jerking?
We gave an intravenous doses of barbiturates in an attempt to help the patient sleep. The result was that they went from story sleep, non-sleep, to
Very
deep
like
coma,
awake, but not
and
really
passive
awake.
sleep stage.
There's the
prior
ataxia.
to his death, Silvano made a selfless offer, bequeathing his brain to researchers.
My goat.
Finally opened.
And so now we can look over the symptoms or the symptomology of FFI right now, and what we know based on research. We know we have a progressive insomnia with a rapid dementia-like symptoms. They have high BP, or they develop high BP, high heart rate, and anxiety. Remember that? They start experiencing hallucinations and myoclonus, which is that jerking that we saw in the video. The average length of the disease after diagnosis is between 8 to 17 months, and after this, they die. There is no current treatment, but there is medication. The first one, we have phenothiazines, which are essentially antipsychotic drugs. They are dealt with people that experience hallucinations and are used for treating insomnia, which is pretty good for this type of disease. It only works short term though. So within these studies, it only worked within the early stages and stopped working after a while. The next one is gamma hydroxybutyrate, which is a narcolepsy medication. A study was done on this medication being used. Late stage fatal familial insomnia, so this guy had weeks to a month to live. He was able to sleep within 30 minutes, which is great progress, but he did not feel rested. So that perception sleep quality is extremely important here, because even if he did sleep, he still was at risk with those conditions. I think we've learned a lot. I feel like that was a lot of information. Let us go back to sleep. Let's take a deep breath. Let's try this one more time. Good morning. That was terrible. We were moving all night. At this point, I don't know when yesterday was today or when today is tomorrow, and I'm having a very difficult time trying to understand my daily life. But we finally move into our case, which you all read, by Wang and colleagues. We weren't given a name, so John Doe is going to be our guy. He was admitted July 2021, which is fairly recent. His symptoms when he got admitted was memory impairment, psychotic disorder, and hallucinations, which progressed while he was in the hospital to some speech difficulties, excessive sweating, and rapid heart rate. The doctors didn't know what they were doing, and they diagnosed him with anxiety disorder, and they treated it as such. And he did not get better at all regarding the meds, and so his family wanted him to exit the hospital, which is completely understandable and should be respected because the doctors weren't doing stuff. We did get an EEG done, and this EEG is completely normal. Whatever this is in the front, don't worry about that. That is noise of him blinking or moving. This is a 10 hertz alpha rhythm, which is normal. I know it looks like brrrr, which seems alarming, but if we put it into a filter and change it to 5 hertz, like for FP1, which is right here, left side of our frontal, or up here, frontal parietal, is going to look like this instead of whatever this brrrr is. So this is a completely normal EEG. Do not worry about this. He is fine in July, at least brain-wise, not symptom-wise. But he got discharged, so it doesn't matter. 4 months later, he comes back with major memory impairment now. He cannot recognize his family, and he cannot eat by himself. He's experiencing more hallucinations. He has ataxia and aphasia. And his EEG has changed into a diffused paroxysmal slow EEG bilaterally, which I'll get into right now. His new diagnosis, we don't know, but it's something genetic. Why? Because it can't be anything else. And so when we look at his EEG, let's break down what this is. We only want to focus about this first 95%. This is noise, okay? This looks very different than the last one, okay? We see all this like buffers of inconsistent, very slow rhythms. And so let's go over what diffuse and slow paroxysmal mean. Diffuse means it's not localized. It is within the entire brain. All of these are different brain regions. T being temporal, T2, everything even number is on the right side, everything odd number is on the left side. So F is frontal, C is central, O is occipital, P is parietal. He is experiencing a diffuse EEG. Now slow is what we see how it's very spread out. Where the last one, if we go back, it was very brrrr. This one is wow, which is bad. Whereas paroxysmal, which I'll go into why it's bad right now, but paroxysmal means it's not consistent. So it is in chunks, which is what we see here. And now let's get into what a slow EEG means. Slow EEGs are often seen within patients that have Alzheimer's. So this is very similar to what a patient with Alzheimer's would have. It is a sign of cognitive dysfunction, blood-brain barrier disruption, and Alzheimer's, and sleep apnea, which is breathing difficulties while in sleep. A study was done to see patients with FFI and within EEG, and a lot of them have generalized slowing without periodic sharp wave complexes, which is periodic sharp wave complexes is slowing and then the bah. So this guy doesn't have that. This is generally what you would see in an FFI patient. We were also given, for John, a PET CT scan, which shows the glucose metabolism, or the energy consumption, by the brain. And we see that it is reduced in these sections. The dark is bad. Dark is bad, okay? This is how a brain, reduced glucose consumption is associated with dementias, right? And so this is just a PET, not a CT, a PET scan of a person with FFI. So here we see the reduced metabolism within the thalamic areas, the basal ganglia, and the cingulate cortex. Now when you compare them, the areas are pretty similar. It's pretty similar among, of course, but it's, anyway. So they are leaning towards, okay, this could be fatal familial insomnia, but we need to do the end all be all for this, which is a genetic test. And when they do the genetic test, they find out that he has the mutation, which is D178N on the 129th amino acid. This is the hallmark for fatal familial insomnia. If you have this mutation on a different amino acid, it is Creutzfeldt-Jakob's disease is the genetic form of that. So this is what makes it fatal familial insomnia. They did it on him, he had that, that's what that means. It's that overlap within here. They did it on his family members, and they all have it as well. And as we discussed earlier, it is an autodominant trait, which means that if you have it, you have and your partner doesn't have it, you have a 50% chance of giving it to your offspring. And every single one of them has it. which is insanely unlucky. Because every single one of these people that are alive are going to get fatal familial insomnia at some point. And he was just the early one. His father died of a car crash, but that is irrelevant considering that his mom was the one that had the gene. That was the plot twist. That's why I said nice attempt to whoever put it could be his dad, which was what I thought too. But this is devastating news to hear for John and John's family. Of course, so I think we should go to bed, try to sleep this one off, figure out what to do next. And we try, and we can't.
Oh no.
And now what? We're essentially just going to stay awake until we die. We're going to stay awake experiencing these symptoms of hallucinations, ataxia, aphasia. But because we're so exhausted, we're not the ones that are going to suffer as much. It is our families. Because while we're going through this extreme exhaustion where we're going to die, our family is going to stay alive, knowing that at some point in their lives, they're about to go through the same things that we just experienced, which is terrifying. And so this goes into that gene testing controversy, which is, should you get your genes tested to see if you have an early death sentence? Personally, I would, because I would like to plan my life in a way that I don't want to plan for retirement when I'm 70, but I want to experience things in my 40s and my 30s before I get this. But a lot of people don't want to. Silvano's daughter did not want to until she had her second kid. And when she got tested, she was free of it. She didn't have the gene, which is really nice. But Silvano's other daughter refuses to get tested. To this day, I don't know if she's alive, but within the point of that documentary that we saw earlier, she did not want to get testing, and which is completely fair, because some people don't want to live with that early death sentence. And so this is not a disease that is terrifying for the patient, this is a disease terrifying for the family, which I think is most devastating of all. And thank you. These are my 4 pages of references. Any questions about anything at all? I think I can answer most of it now.
For that medication that helped them fall asleep in the one study that you brought up early on, do you think that the standard treatment for the people that are in this haze getting put on this just medication and knocking them out even though they're still going to die? But they said they didn't feel restful, so.
They didn't feel restful. It's at least, they didn't feel restful, but at least it's something. I'd rather take that than staying awake.
Than being hallucinating the whole time you're awake, right?
What they did for Silvano was they put him under some drug that essentially works as an extreme sleeping agent, but it skipped the sleeping and they put him into a coma state for a good while. I don't know if you talked about it there, but there's no standard treatment for FFI right now. These are just some experiments that have been done because it's such a devastating disease and trying to help that quality of life because it's so bad. This one kind of working on the late stage is good news, but of course, if it can be tweaked, that'd be really nice. To be able to, because if it's late stage and they're able to get some sort of rest, it would be nice to take that before I die. Like, maybe take that and then just like euthanize, I don't know.
Yeah.
Or not euthanize, is that the word?
Well, I mean, if you're a property owner in Oregon, you can
There you go.
euthanize yourself.
But any other questions? Any other
Specifically property owner.
You can
Oh,
euthanize
yeah,
yourself.
you have to be a property owner to get physician-assisted suicide in Oregon.
Can you own like this much?
I think so.
Period.
What's
A lot.
Buying
there
a
like
square
a-
foot right now.
You can own a lot.
So like someone could purchase like a big thing and then cut it up into like 90.
No, I think you have to own a technical lot of land. Sorry, Jackie.
This is not.
What's the thought process behind
The thought process is a bunch of people would go there to off themselves. And so in order to stop travel death, I mean, we call it medical tourism when we go to other countries to get medical treatment. Death tourism right, to block death tourism, they make you be a property owner.
What if you like buy a property there and Airbnb it?
True.
Well,
But it's
that's
still
Buy-
yours.
buy a
You're the one
duplex.
owning it though.
Yeah, you still own it, and then you can rent it out, right, and make money off of it until you decide to go retire there, so you can off yourself when you need to.
What's to sign a co-lease?
And your time is up. Thanks, George.
I didn't like your last picture, the pillow one.
I just searched up Insomnia art, and
Wow.
that one was the one
I didn't
that
like
spoke
that.
to me the most.
It scared me because why is he like in the pillow? But he has no neck.
Because it's like Freddy Krueger.
Is it just like an outline of his, like, is his head like in? Or
Freddy
is it-
Krueger looks like.
Thank you. I'm exhausted.